Hi there, everyone. What a wonderful morning it is in California. I just came from the East Coast yesterday, and there's still snow on the ground, and rainy. The weather was kind of miserable, so it's always really wonderful to come to California to see all the faces here today. So today I've got some of the material has been covered already. A little bit about the foundation. I'll cover that very briefly. I want to talk a little bit about what we do to understand Parkinson's at some of our research programs. Again, I touched on a little bit, so I'll kind of move through that quickly as well. But what I'd really like to talk about is our precision medicine initiative within the realm of Parkinson's disease. Because I think this is an area that's really exciting. Precision medicine may be a word or phrase you've heard applied to cancer, where specific medicines are created for specific types of cancer or specific gene mutations in cancer. We're not there yet for Parkinson's disease, but we're getting close. And so I think that's a really exciting future where we might go when it comes to Parkinson's disease. So I just want to talk a little bit about that and how we, my colleagues at the Parkinson's Foundation, and with the help of the community at large, are helping Parkinson's get ready for the next generation. So you've heard our mission statement before, and I can't emphasize enough that what we're doing is to help people today and help people with Parkinson's for tomorrow. And we involve people like Karen, people who have Parkinson's disease in everything we do. So we're always involving people with Parkinson's as part of our efforts. When I talk about our research programs or research grants, we have people with Parkinson's who are sitting in to review those grants as well. So that what we do as an organization, we ensure that it has the feedback from the community so that it has impact for people with Parkinson's disease. We're unique in how we do that. We've talked about before, we're a national organization. We have centers of excellence throughout the country. We have moving days. And we have events like these. So what that means is we are a foundation which is really involved with the Parkinson's community. We are truly a grassroots organization. And we have a lot of impact for people with Parkinson's disease. There's ways with which people can receive their care at our centers of excellence. They can call our helpline, which we now have extended hours for California. So we can extend it till, I think, 5 or 6 p.m. California time. So that's something that's very useful, and have multiple languages available as well. We can engage people with research advocates. People can receive help from physical therapists who've been trained by the Parkinson's Foundation. These are different ways with which people can feel the impact of the foundation. And we know that people who have engaged with the foundation, that have used our materials, they've taken advantage of what we offer, have better outcomes when it comes to the progression of Parkinson's disease. And so this is a comparison based upon some research that we've done, and it basically shows that on the left in blue, a lot more positive effects from people who've actually engaged with the foundation. These are people who have Parkinson's disease, who know about different national organizations, but our educational materials are fantastic. The resources we provide as an organization, I think, are top-notch. And so those individuals who were able to come across the Parkinson's Foundation and utilize the resources we have better quality of life, have better outcomes as a result of that, we believe. And so one of the things we're going to be doing as an organization is to try to reach out to those who've been newly diagnosed by Parkinson's disease. Because if we can help them at the start of their journey with PD and be with them through their entire journey, I think they'll have an easier time as part of it. And so, hence, that's kind of our tagline, better lives together. Us working with you in the community, I think, can lead to better lives for people with Parkinson's disease. And there's many different ways to get involved. Movie Day is one of them, events like this, and they're all really important ways to do that. And what that has meant is by people who've gotten involved with the foundation have really responded to what we're doing. And our growth has been phenomenal. We're set to double where we were in size just 5 years ago. And so what that means on a practical level is we're able to do more as an organization. And I'm going to talk a little bit about that. One of the things we do, and this is something Sarah's mentioned about, we're able to fund over $10 million in research annually for Parkinson's disease. We have a whole list of different grant opportunities. There's not necessarily to read them all here, but just to give you a sense that there's a breadth of research opportunities that we offer to scientists to encourage them to get into Parkinson's disease research. This is Beth Bernaleo, she is on my team and leads these programs. And they have real impact. We fund moving disorder fellows. Dr. Tanner is one of the very first fellows that we funded as a foundation. We are looking to support the careers of young scientists, young faculty members. Dr. Nelson is a recipient of our Fawn Scholar Award, and so she's one of the very first of those. The idea is, what can we do to keep people engaged in Parkinson's disease? These are smart people. They have the world as their oyster, and as they try to choose careers in neurodegenerative diseases, we as a foundation want them to focus on Parkinson's disease as part of their research, part of their careers. And so the idea is to help develop them professionally, especially scientists who have really interesting ideas that could potentially help Parkinson's disease. And so we have a variety of ways with which we do that. So I want to also talk about some of the other things we do as an organization, which may not seem so researchy, but have a real impact, I think, on the overall landscape of Parkinson's disease. And that was, one of them was asking the very basic question, who has Parkinson's disease? And what you may be surprised is that it's not such an easy question. The last major study was done in 1978 in Copiah County, Mississippi. And Copiah County is located right here. There's a map of the United States, and the little red dot shows you where Copiah County is. It's a very rural community, county in Mississippi. At the time in the 70s, it was a population of about 40,000 individuals. And they did, as part of this epidemiology study, looking to see who had Parkinson's disease, they did a door-to-door surveys. Very high-quality study. They surveyed 9,000 individuals looking for people who had PD. Do you know how many cases of Parkinson's disease they identified? Anybody want to hazard a guess? Just shout out a number. 100? 400? 800? Because this study, even though it was very good quality, was kind of limited in its scope, but they utilized that to extrapolate to how many people in the United States had Parkinson's disease. And they found, just another thing about 1978. This is what happened in 1978. Microsoft, all 11 employees. A startup company. Social media. Remember the black and white TV at the kitchen table? And here's the SUVs of the 70s. So a lot has changed since then, including who has Parkinson's disease. And so of the cases of Parkinson's they found in Copiah County, they found 26. That's it. They found some people who had some Parkinsonism, but it was 26 cases of Parkinson's disease. And they used that to extrapolate to the entire U.S. population, which now is about 330 million people. We are a very ethnically and geographically diverse country, and Mississippi isn't necessarily representative of that. It was representative of the fact that it was a biracial community, and solved the question at the time was, for people who are black versus whites, what was the ratio of developing Parkinson's? And it seemed to conclude that there was about equal prevalence of PD amongst them. So what we did as organizations wanted to update those numbers, create a new estimate. We weren't going to have a true number which would be the one to stand by, but what we could do is we can improve our estimate of who had Parkinson's disease. And Dr. Tanner, who's going to speak later this morning, was a principal author on this, and she helped lead our effort as part of this, as did Dr. Maris, who's at the University of Toronto. So what we did is we pulled together different data sets that we had, contemporary data sets of who had Parkinson's disease in different communities. One of them was a Kaiser Permanente database, which is represents Northern California, and we had clearly thousands of people who had Parkinson's disease amongst close to several million individuals. So we had a better sense of determining who had Parkinson's disease in North America. And so what we've done is we published that data this past summer, and we're able to take a look and apply those numbers to who has Parkinson's disease in the United States, and come out that there's nearly 1 million people with Parkinson's disease by 2020 in the United States. And you can even use those numbers to get an estimate of who has Parkinson's disease in California. But this is just an estimate. So this is not refined numbers. This is just a better guess than what we had before. And so there's still a need to be able to go further and improve these numbers so we can really have a sense of who has Parkinson's disease. Because it's important for several reasons. So if you're a congressperson in Washington D.C. and you're trying to think about how money should be allocated for research or for Medicare, knowing how many people have Parkinson's disease can influence those decision making so that more money can be allocated for Parkinson's disease research. More money can be allocated to help support the training of neurologists, perhaps, to take care of people with Parkinson's. This is a type of public health data that's really important. We're working, so this is something we've done, and there's other efforts underway to understand the economic burden. What is the societal cost of Parkinson's disease? And we're also working with this group again to understand how many people are diagnosed each year with Parkinson's disease. That's something that we still don't quite know yet. And if you want to, you can go to our webpage, parkinsons.org statistics, and take a look at some of these statistics. Oh, and I should say, this paper is published in NPJ Parkinson's Disease. This is the official journal of the Parkinson's Foundation. It's open access. So if you have an interest in Parkinson's research and want to just be able to download papers for free, you can go to NPJ Parkinson's Disease, and all the research papers have a lay summary, about 100, 150 words. It will give you the gist of what the paper's about, even though you're not a scientist necessarily. And so you can have an understanding of what the article's about. And if you're curious about it, you can do that for free. And that's something we're committed to ensure that people have access to science about Parkinson's disease, because we think knowledge is a way to empower individuals. Our outcomes project, so I mentioned a bit about it. Dr. Kublos, Fernando Kublos, in our Miami office is a lead behind this. And this is a data collection natural history study for people with Parkinson's disease. And to really better understand Parkinson's disease and improve care and improve the outcomes. It's an ongoing study, started about 10 years ago. It's a patient registry which would capture a lot of basic information about people with Parkinson's disease, medications and whatnot, as Sarah said, to really understand where people are with their disease now, their care that they're receiving, and see if there's a way we can turn the art of care into the science of care. And so that's currently undergoing. We, as Sarah pointed out, one of the findings is that people who exercise generally have better quality of life. So that's something to help support what we say all along is that people should exercise with Parkinson's disease. But we found some other correlations as well that people with comorbid diabetes have a risk of cognitive impairment, and trying to understand predictors of PD for people who might encounter psychosis and falls. So what I want to do is switch gears yet again, because I'm talking kind of a broad range of research, to talk about causes of Parkinson's disease. And unfortunately, I didn't put my slide together build right, but what I wanted to do is just tell you that basically 90% of all cases of Parkinson's disease, as you may know, occur for reasons we don't know. They're idiopathic cases of PD, but about 10%, maybe 20, depending on how you kind of slice the numbers a little bit, are thought to have a genetic component to the Parkinson's disease. So this genetic or familiar PD component of PD represents about 20%, let's say, and there's a list of some genes over here in the little box on the right, and we have the big great unknown over there in the rest of the pie. And so the statement is that Parkinson's disease is a likely combination of genes and environment. It's a kind of a kitchen sink approach. And one might say, what else is there besides genes in the environment that can potentially influence Parkinson's disease? But there's lots of things that can be involved that we yet to understand when it comes to Parkinson's disease. And here's a whole list of some of the key Parkinson's genes, in addition to the ones that were there. This is from 2015, so it's a little old. There's a couple more genes that have been added to this, just to let you know that it keeps growing as science progresses. And one of them that's of note is the very first one. It's alpha-synuclein, the gene that encodes alpha-synuclein. You probably all have heard about alpha-synuclein, this protein that gets misfolded in the brains of PD. One of our very first research fellows, Dr. Roger Dubuisson, was part of the team which helped identify the very first gene for Parkinson's disease in the late 90s. Before then, no one thought that Parkinson's disease was actually a genetic disease or a family disease. Another gene of note is LRRK2, leucine-rich repeat kinase 2, LRRK2. I'll talk a little bit more about that in just a minute. And then there's a whole bunch of risk factors. So these are ones that, and the one for encodes a protein called GBA galactosidase. is another important risk factor for Parkinson's. And I'm highlighting these for a reason, so I'll come back to them, but just to kind of let you know that, again, there's lots of genes which can be associated with Parkinson's disease. But it's those genes, even though there are many of them, really represent very few cases of PD overall. But that's important as well. So the question then, as I pointed out, is if genetic forms of PD are so rare, why is there always, you may hear in research talks, such a focus on doing genetic forms of Parkinson's disease, trying to understand genetic forms of Parkinson's disease? Shouldn't scientists spend all their time trying to understand this great unknown component? And I would let you know that I think that's not the case. Sometimes it's easier to go after known causes of a disease than not. One of them, I think, is here, a tale of genes. So there's two men I've shown here on the slide. And this is one is Jim Fix, who you may know was a runner. Helped really start the running movement in the United States. Runner's World magazine, I think, is what he helped found. Died of a massive heart attack while running in upstate Vermont. Died at 52. Winston Churchill was a man on the right who was not so athletically inclined. He liked to drink a lot, smoke a lot, eat a lot, had stress in his life too, yet still died at 90. And so what's the difference between these two men? And it all comes down to genes. This is the biosynthetic pathway for cholesterol in the body. And you don't need to really understand this, but the point is it's a complex process. And understanding a genetic mutation, which Jim Fix likely had for making cholesterol, and people have that mutation, they have a disease called familial hypercholesterolemia. Anyone heard of familial hypercholesterolemia or know someone who has familial hypercholesterolemia? A couple people. Anybody know anyone who takes statins? Yeah. So you know a lot of people. So very few people have familial hypercholesterolemia, but understanding that genetic cause to high cholesterol led to the development of statins. And statins, which not only help people with familial hypercholesterolemia, can also help people who have high cholesterol for other reasons. And so, as a result, understanding the genetic form of a disease can potentially, not always, but can potentially lead to helping people who don't have genetic forms of disease. And that's what I'm going to is with Parkinson's disease. So when we talk about genetic forms of PD, we're potentially talking about rare cases of Parkinson's disease that may inform the larger population of those living with Parkinson's disease who don't have genetic forms of PD. And so therapies which get developed for them may, and fingers crossed, because we still have yet to solve any form of PD, much less genetic forms of PD, could help people in the greater population. So let's focus again back on LRRK2. Why are those important? So LRRK2 is a mutation which affects, it's one of the more common mutations which affects people with Parkinson's disease. About 5% of all PD, those with PD in their family, and 50% of all Ashkenazi Jews with Parkinson's disease likely have a mutation in this particular gene. And there's 6, in red here, are the sites of mutation in this very big gene that seem to be pathogenic, that seem to cause Parkinson's disease. What's interesting is that if you have this mutation, you're not always guaranteed to develop Parkinson's disease. Only about 30% of people who have this mutation will develop Parkinson's disease. If I told you there's a 30% chance of rain today, you probably wouldn't even walk out of the house with an umbrella. So having a 30% chance of developing the disease is not guaranteed that you'll develop the disease. That's always something to keep in mind. People are really bad at understanding odds. But so, it's just something to keep in mind. If you know someone who has this particular mutation doesn't have the disease, maybe they'll develop Parkinson's disease. GBA is another mutation. GBA is important. You may have heard about it because it's 2 of these mutations that someone may have leads to a condition called Gaucher's disease. It's a recessive inherited disorder that can lead to problems in brain development. It can lead to early death in some severe types. And other people can seem to survive on it and get regular treatments. But having just one mutation in this gene seems to lead to a very increased risk of developing Parkinson's disease for some individuals. And so, it seems to be, again, one of the more prevalent mutations in people who have Parkinson's disease. there's a whole number of these variants as part of it. Here, there's well over 300 variants or changes in the gene, which could lead to Gaucher's disease. And there's just some points right here on the bottom, just showing some of the more important mutations that are in the gene. There'll be a reason why I'm showing you all these little numbers here in just a second. So bear with me on that, if it seems confusing. So when we talk about precision medicine, the idea of these genetic forms of PD, it leads to the idea of precision medicine. And next generation clinical trials, it's actually here, take advantage of some of these things. So there's a trial underway right now by Sanofi Genzyme that targets specific forms of mutation in GBA. So individuals with Parkinson's disease who have a GBA mutation are eligible for this particular clinical trial. And they're trying to recruit over 200 participants in what's called NEWS PD. And then there's a trial, phase 1 clinical trial started by Denali in the Bay Area, looking for people who have Parkinson's disease and have a LRRK2 mutation. So, these trials are here trying to identify individuals with Parkinson's disease who have these mutations, these very few individuals. And there's a bunch of other companies that are in the wings with their own studies that they're trying to develop, their own drugs that they're trying to look for people to recruit for Parkinson's disease. And looking probably for several thousand people over the upcoming years. But we are not ready. Who here in this room knows their genetic status if you have Parkinson's disease? A handful of people, right? Most people don't know their genetic status is really what it comes down to. When you try to recruit for a clinical trial, and you're trying to identify the right population, and no one knows who those individuals are, it's like saying, I'm only looking for people who have a square on their back. I can't see my back very well, so no one really can tell, and everyone wears shirts generally, so it's not like people can just identify them in the crowd. This is kind of the situation we're in. And for those of you who might have done direct-to-consumer testing as part of your understanding your genetic status, the problem is direct-to-consumer testing really didn't look at all the different variants, the mutations in those particular genes. Remember, I showed you those pictures with LRRK2 and GBA, and I had all those different variants. Only a handful were identified by something like direct consumer testing by 23andMe or other providers. So this little circle here on for LRRK2 and this little circle for GBA are the only ones that are identified by 23andMe's current report. There's a bunch more variants which could be impactful for Parkinson's disease. So we're not getting comprehensive information about that. And I've spoken to a number of clinicians who had patients who've done this type of direct-to-consumer testing and trying to understand the results. They often misinterpret the reports. It was, can't make heads or tails of it. My postdoc advisor, it's one of the reasons why I've gotten Parkinson's disease. His wife has PD. She's a scientist. They're both scientists, and she has LRRK2 mutation. And so they did 23andMe. They couldn't understand the report. They had to go to the primary literature and read the real science papers to really figure out what it was trying to tell them. So these are two people with PhDs who are neuroscientists, not just regular PhDs who do epidemiology or other important things, but really knew this stuff. And they're having a hard time. So I imagine the general public is having a hard time too. So reporting is not comprehensive. So what companies can do as a way to try to change this is that they could go out and offer genetic testing to groups of people. But the problem is we're going to get a balkanization of the population because Denali's going to go offer free genetic testing to some people, and Merck's going to offer some genetic testing to other people, and so on and so on. And are they going to share that information to people? No. Are people who've gone through the genetic testing going to want to do multiple times? No. They're like, I've already done this, doc. Why do I have to do this again? And so the problem is that data is going to be balkanized. It's going to really, I think, hinder research, hinder the advancements that are necessary within the Parkinson's community. So we're trying to change that. This is Anna Naito, and she is leading this program for the foundation. So we announced last year, about this time, excuse me, a new initiative in which to offer free genetic testing and counseling to people with Parkinson's disease in a clinical setting. So this is not some kind of web-based program. This is going to your doctor, signing up to a clinical study, because this is a clinical study, informed consent, the whole 9 yards. and having blood drawn and get tested for Parkinson's-related diseases, genes. And then having a genetic counselor, either a clinician or maybe a telemedicine, speak to someone on the phone who's a genetic counselor, have them explain the results that come back. By and large, most people won't have a genetic form of PD, as I've shown you. Most people don't, but some people do. And then that can be useful for two ways. One, it can empower people to better understand their disease. Identifying people who have genetic forms of PD could help clinicians, like Dr. Nelson and Dr. Tanner, to think about new ways with which they can help people with Parkinson's disease. And on a very pragmatic level, can potentially help people identify they have a genetic mutation. So when these clinical trials come around, they can say, hey, I've got this mutation. Let me see if I can enroll in this trial to help Parkinson's disease move forward. And so we have our studies called the PD Generation Initiative, Mapping the Future of Parkinson's Disease. We're going to launch it this spring in 6 sites in the US. And then in about a year's time, we're going to be moving to all our centers of excellence. UCSF is one of our centers of excellence, so we'll be there offering this program to people with Parkinson's disease. It's an all-comers study, so what that basically means is you have to be diagnosed with Parkinson's disease, and then you can participate. And that's a key thing. Here's our steering committee, an august group of scientists and clinicians. And Ann Hall is, I want to point out, she's out of the Bay Area here. She's a woman who lives with Parkinson's disease, and so does her spouse. And she is part of our steering committee to help ensure that what we're doing is informed by the Parkinson's community. And it doesn't hurt that she used to work for CMS, Medicare, as an attorney, so she can help with some regulatory side of things too. So that's really good to have. So as I mentioned, we're going to begin enrollment this spring with about 600 participants, and we plan to expand to all our centers of excellence plus extra sites that are not part of our centers of excellence, because our goal is to do this for 15,000 individuals with Parkinson's disease. Free testing, free counseling. The idea is to help get the community ready for the next generation clinical trial. So, questions you may have? Hopefully I still have some time. So, I went kind of fast because I'm speaking quickly, so I'm from the New York area, and that happens. So, yes, sir. So that map is just simply based upon what is the technical terms population structure. So, like for instance, if there are a lot of, so the biggest risk factor for Parkinson's disease is age right now. So if you look at a state that has a lot of people who are older, like Florida, for instance, then you're going to find, just based upon that correlation, there's likely to be more people with Parkinson's disease in that particular state. So what we just simply did is we understood at the different age ranges what is the likelihood of finding how many people with Parkinson's disease, and just applied a kind of like a mathematical formula to that particular state. This is only an estimate, of course, though. And this probably really represents the floor of who has Parkinson's disease in the United States. And so we just applied that to the various states to give a sense of how Parkinson's disease is distributed in the United States. And it's really based upon large states, or states that have a larger, older population will have more people with Parkinson's disease than states that are less populated, like Montana and Wyoming. They still have roughly the same ratio of people with Parkinson's disease versus other states, but it's just the population structure is different as a result. Does that answer your question, or maybe it's too technical? So the purpose of the study was just really to try to get an updated sense of the numbers. And what we hope is that other members of the scientific community will be able to take a look at that and then do that. I know that Dr. Tanner and her colleagues here in California have been looking at that for pesticides in California. And so it would be useful to try to take a look at that on a larger scale.
Is there a correlation coming up to brain trauma, radiation, in other words, things like that in the past?
So I don't know about radiation, but there certainly is an increased risk for Parkinson's with past past traumas. And I don't want to steal Dr. Taylor's thunder because I think she may be touching a little bit on some of the epidemiology behind that risk factor. So I'll just do that yes, there is. Yes, sir.
Could you characterize the pace or the funding level or the focus of the scientific community and pharmaceutical companies on PD? Where in the totem order?
So, Parkinson's disease, I don't think gets the. So the question is, I don't know if everyone heard that. I just realized it. I can hear it well because they're talking to me, not to the back of the room. So the question was about how does funding level compare for Parkinson's disease compared to other diseases from pharma and stuff. There's a real concern. So pharma, for instance, some companies have dropped neuroscience altogether as far as part of their strategies to develop new drugs. So that's a concern. When you think about the societal cost of Parkinson's disease, the numbers are staggering. Billions, like $25 billion are some numbers that are coming out. The NIH is only spending about $180 million on Parkinson's disease research. We are a $30 million organization roughly, and we only have only spending about $10 million on research. We do many different things. I know there's the Michael J. Fox Foundation. They spend a fair bit on research as well, but altogether, it's a small drop in the bucket compared to what's going on. So I would like to see more money being spent for Parkinson's disease research, and so getting some of those public health statistics is really important to help drive that conversation to be able to move forward. So it's also important for pharma too, understanding how many people have Parkinson's disease, really because these are people who have green eye shades on and trying to think about, is it worth going after this market to spend what could be billions of dollars for a company to try to solve something. If the payoff is not there, then they won't do that. So establishing that there is a sufficient number of people with PD in the country is important. So these are the kinds of things that not only influences government, but also could influence private industry as well. One more question, please. Yes. So I would, because the question is what was tested originally. If they did the direct-to-consumer testing with like 23andMe, and it came back with a report, chances are, that they found like most common variant in LRRK2 is called G2019S. And so if they had the G2019S variant, I don't know if they would need to undergo additional testing. But if they didn't have a variant, then it might be worthwhile to do that. Because we're not only going to look at LRRK2 and GBA genes, but we're also going to look at 5 other additional Parkinson's-related genes as well. Alpha-synuclein gene, which is incredibly rare, Hink and Parkin, which are often associated with young onset Parkinson's disease. Another one is called DJ1, or it's now called Park7, and VPS35. These are really rare mutations, but we can test for them, so we might as well do that as part of this process. So, again, by and large, majority of people will not have a genetic form of Parkinson's disease, and that can be useful too. When we're looking to start this study up, we talked a lot about it before doing that. Spoke with people at another foundation called the Foundation for Fighting Blindness. There's over 100 different forms of genetic forms of retinal blindness that are out there, all incurable. None of them are treatable. But for the participants who went into that genetic testing program, just understanding that they had a genetic form was really useful. There's knowledge has a certain power to it in itself, and it could be reassuring. So if you go through this, and since we're testing a fairly comprehensive set of genes known at the time, because science is constantly expanding, like I pointed out, there's a list of PD genes, and it's an old list, new ones are being added all the time, but current state of knowledge to take a look at some key PD genes. If a person doesn't have those variants in those genes and they have PD, chances are they probably don't have a very common genetic form of PD. And that could be reassuring because it could mean that maybe my children don't have to worry about having a genetic form of PD. So there's many different ways to kind of look at this. So Sarah, I don't know how I'm doing on time, but I just want to 5 minutes. Okay, so I've got some more time for questions. Yes, ma'am. So this is the California Senate bill. Okay, so I'm going to let Dr. Tanner talk about that. She's heavily involved in the registry project for California. I'm less attuned to it. That said, there's been an effort on a federal level to take a look at this. And so I'm going to be at the CDC bill headquarters in Washington next week, working with other PD organizations to talk about how can we really improve our numbers of who has Parkinson's disease in the U.S. As I said, the work we've done was just a better estimate. It's a better guess, more accurate guess, but it's not the definitive numbers for who has PD in the United States or California. But it's an important improvement over where we were, and we still have a ways to go. So anyway, with that, I will step down because I'm getting close. Of course. One more question. Yes.
Do they know why some people come down with Parkinson's at an early age, some at middle age, and some at elderly age? Is there a reason for that?
Yeah, so the question is about age of onset for Parkinson's disease. That's a really good question. Young onset Parkinson's disease, which is variably defined as less than 40 or less than 50 years of age and developing Parkinson's disease, often has a genetic component. So people who have young onset PD, 30% of them often have a genetic form of PD. But again, 70% don't. So I don't understand myself, and maybe Dr. Tanner can talk about some of the different risk factors that are involved in Parkinson's disease that could play a role in that. But one would expect this is where environmental and genetic influences can play a role in it. There's a lot to learn. The fact of the matter is PD remains a very complex disease, and there's a lot for everyone to do to try to help solve this. And it's, we're making progress where we can. Thank you very much for your time.